This is the note set or explanation on the gas law drawings and what we want you to do. So we're going to do an example for you on Avogadro's law, and then you're responsible for Boyle's law, Gay-Lussac's law, and Charles' law. Please make sure that these are real-world examples and not just the pictures from the notes, because that's not going to help you at all. So again, please do real-world examples for these drawings. So here's a real-world example drawing for Avogadro's law. So the equation for Avogadro's law is actually a little bit more the ideal gas law, and so there's not really an equation that we will cover quite yet. And so basically with Avogadro's law, we're just going to be dealing with volume and number of moles. So since those are our two basic variables, the things that are held constant here are pressure and temperature. And so with Avogadro's law, if pressure and temperature need to be held constant, if my volume increases, in order for pressure and temperature to be held constant, then my number of moles needs to increase. And so this is a direct relationship, and a relative graph would look something like that. I'm not going to be as much of a stickler on the drawing graphs here. I don't really need a title or axes labeled or anything like that right now. It's more just what's the shape of the line for that graph relative in terms of direct or inverse. And so I know I'm not really following my directions right now in terms of how much of a stickler we've been on graphs, and so just do that relative what the shape of the line would be. So Avogadro's law, the example I want to use is looking at a balloon being filled with helium. So if we have our helium tank and we have our empty balloon, we know that the number of moles in volume would be a certain value, and if I increase the number of moles in my helium tank, or in my balloon using my helium tank, I know the number of moles of helium has increased because the amount of helium has increased. And so by doing that, in order for pressure and temperature to stay constant in this case, I would need my volume to also increase, because if my volume didn't increase, my pressure would go up if I increased the number of moles. And so we need our volume to also go up, which is what you see with the balloon. So my picture is showing that the balloon got bigger, and we're showing that the number of moles got bigger and the balloon got bigger. And so then on the back side of your paper, what you're going to do is explain in words what happened. So in words, what happened in my picture is I'm saying the number of moles increased, and in order for the pressure and temperature to stay constant, the volume has to increase of the balloon. So I could add in like that I'm working with the balloon. So the other thing that you're going to do here is also discuss the properties of a gas, or list the properties of a gas, the differences between a real and an ideal gas, and then you're going to talk about the 5 assumptions of the kinetic molecular theory. So this is basically your review for the first part of the gas law test as well. Okay, so thank you for watching that and doing the example.